Kia ora. Here's another question from the 2022 May-June paper for stats. This is paper 63, and it's question 5 on the Poisson distribution. And it's it's a pretty basic question, but it summarises a lot of the key things that we learn in A-level about the Poisson. Okay, we've got the number of clients who arrive at an information desk has a Poisson distribution with a mean of 2.2 per 5-minute period. Find the probability that in a randomly chosen 15-minute period, exactly 6 clients arrive at the desk. Okay, so that's going to be a straightforward one where we just need to change the value of lambda, which is the mean parameter, because here we're given it for 5 minutes and in here we need it for 15 minutes. Just looking at the rest of the question, the next one is about back to working with a 5-minute period, and we're told that if more than 4 clients arrive during a 5-minute period, they can't all be served. So find the probability that not all the clients who arrive at the desk can be served. So that's I think, a pretty easy Poisson one by the standard of the usual A-level question, where we're going to be working out the probability that X, the number of customers who arrive in a 5-minute period, is greater than 4, right? So just think about it. If 4 arrive, that's fine, okay? If we have 5, 6, 7 or so on arrive. So that's going to be working out the probability that X is greater than 4. And in the last part, we're told to use a suitable approximating distribution to find the probability that during a randomly chosen 1-hour period, fewer than 20 clients arrive at the desk. Okay, we'll get to that in a minute. So let's do the first two quickly. Question 1, we need to change lambda. So we've got lambda equals 2.2 for 5 minutes. For 15 minutes, we need to times it by 3, and we get lambda is equal to 6.6. Right, that's 5 minutes here, and it's 15 minutes here. Now we have to work out the probability that X is equal to 6. So we apply our formula, e to the negative lambda times lambda to the power of 6 divided by 6 factorial. And when we chuck that into our calculator, we get, let's have a look. Right, we end up with 0.1562, which is 0.156 to 3 significant figures. Okay, next question was the one where we're back to having a 5-minute period, and we want to find the probability that X is strictly greater than 4. So as you know, when we're working with a Poisson distribution and we have X is strictly greater than 4, that means 1 minus the probability of 0, 1, 2, 0, 1, 2, 3 or 4. Too late at night, haven't had enough coffee, can't count. There we go. Just be careful always with those endpoints. If you are likely to make mistakes, then it's worth just doing little dots and thinking about what do we want to include and what do we not want to include. Right, so it's more than 4. Read the wording carefully. Now we can work that out. I think the fastest way to work it out is like this. So we go 1 minus, and then we're going to take out the common factor of e to the negative lambda. Lambda here is back to being 2.2, not 6.6. And then we have the 0 probability will be 1. The 1 probability will be just lambda. Then we have 2.2 squared on 2 plus, let's keep on going, 2.2 cubed on 3 factorial, which is 6, and 2.2 to the power of 4, which is 4 factorial, 24. Now, if you're watching this and you're in my 13 MCA class, you'll be really used to how I do that, to do Poissons quickly. Other people have got different ways. It's cool. Do it whichever way works for you. Right, now when we chuck all that in the calculator, we get 1 minus 0.9275 and stopped it about there. And that gives me 0.0725, again, to 3 significant figures. Okay, now let's have a look at this last one. So this is really the only one on this question that I think you should have to think about. Those first two really should feel pretty easy by the time you're getting close to the exam. In the last one, we're going to use a normal distribution, and we're going to do that because we're working with a randomly chosen 1-hour period. So the first thing to do in here is to say that lambda is 2.2 for 5 minutes, So for 60 minutes, we have to times that by 12. And that will give me 2.2 times 12, which is 26.4. And you can see that's well over the level that's going to make my Poisson distribution be shaped pretty symmetrically and look an awful lot like a normal curve. I think from memory that its lambda is 15 is our cutoff for that, but I need to go and check that. Anyway, we're well above it, and we're not asked exactly about assumptions here. We're just told to use a suitable approximating distribution. So when we do that, what we're going to do is we're going to have our x is our Poisson variable. So x is Poisson with a lambda of 26.4, and I call my approximating one x dash, and it's going to be roughly normal. It will have a mean of 26.4, and it will have a variance of that as well, right? Remember that that's one of the cool things about the Poisson distribution is that the mean and the variance are equal. So now all we've got to do is to figure out the probability that we've got fewer than 20 customers. And this is where we just need to take a breath and think about what we're doing. So we want to find the probability that we've got fewer than 20 clients arriving at the desk. Remember that the Poisson distribution is a discrete distribution. So if we're thinking about the actual X distribution, who do we want included? Well, we want the situation where we've got 18 customers arriving in an hour or 19, but we don't want that. X is probably a stupid thing to write there. We don't want the 20 bar. And that tells us that when we do our continuity correction, we're going to go to the edge of that bar there. And so our probability will be the probability that X dash is less than 19.5. All we have to do now is standardize that like we did when we did AS. So we subtract the mean, and we divide by the standard deviation, which is root 26.4. We do that to both sides of the inequality. I'm doing that slowly so that you remember where the standard normal is coming from, right? So it's probably that Z is less than, what's it work out to be? Negative 1.34291. And that's equal to this area here, which is 1 minus phi of 1.343. And that gives me 1 minus 0.9105 and a final answer of 0.08. Oh, what's happened there? Something weird's just happened. 0.0895. Okay, so there you go. That's all for tonight. Keep on sending in the questions, and I'll keep on videoing some past paper questions.